Hi, friends. New topic today. We are talking about exponential functions. So, it's a new type of function on our function family tour. And I know you did some work with the sliders on Desmos. So, I wanted to talk about that again. So, let's take a look here. Now, the same rules apply like those functions that you've seen before. But here's our new parent function. Here's our new starting point. So you looked at y equals a times b to the x minus h plus k. And let's take this parent function f of x equals 3 to the x. And I gave you some descriptions of the transformations. So a reflection over the x, a stretch by a factor of 4, and we're going to move right to and up 5. I don't know what's going on with this curl today, in case anyone was wondering. Crazy hair, don't care. I don't know what's going on. So, whatever. Also, thing 1 and thing 2 are playing outside with my brother. So, if you hear them outside the window, someone's watching them, I swear. Okay. I don't know what's going on. Anyway, whatever. Okay. Don't mind how wild and crazy thing. Okay, anyway, here's your parent function, f of x equals 3 to the x. So if I wanted to reflect over the x, remember that's going to put a negative in the front. A stretch by 4. So that's that a, right? That 4 is going to go in the front because I want it to stretch by 4. And I want it to move right to, remember, right and left go with the x, and up and down are going to go after. A right or left goes with the x. It does the opposite of what you think. And up or down does exactly what you think it's going to do. So here's my f of x. A reflection puts a negative. A stretch by 4 puts my 4. Now I have times. Now it was 3 to the x, but I want it to go right to. If I want it to go right to, so I would want a plus 2, but remember it does the opposite of what you think. So it goes right to and then up 5. So there's my plus 5. If I want it on the same line, I'm going to fix that. So there's my plus 5. Okay, so there. A reflection over the x, a stretch by a factor of 4. There's the 3 because that was my parent function. It goes right to up 5. Now this one, here's my new parent function. F of x equals 0.5 to the x. And now here's my new function. G of x equals a half times 0.5 to the x plus 3 minus 4. And what I want to do is describe the transformation. So now I want to go that opposite direction. So tell me what happened. So is it a reflection? Is there a negative? No. That half in the front, yes, there's a 0.5 there, but that's from that. So that half in the front means there was a compression. You could also say stretch by a half. You can't just say a stretch, remember? You could say stretch by a half, or you could just say it's a compression. This x plus 3 is going to do the opposite of what you think, and it's with the x, so it goes left 3, because with the x goes right or left, and it does the opposite of what you think, so that goes left 3, and then that one goes down 4. So that goes over those transformations. And then I will post the answers to your work after the extra credit deadline is up. So you'll have to wait a little bit for those. Okay, so think about those. Think about any questions you may have. Comment with those questions on Google Classroom or in my email or on Remind. Okay, so now let's talk about some more exponentials. So let's think about y equals ab to the x. That's the main idea for exponential growth and exponential decay. This is kind of, I don't know, a really appropriately inappropriate topic at this time, because exponential growth and decay, we actually talk about a lot in the science field when it comes to diseases and epidemics and kind of what's happening, where something grows a lot in a really short amount of time. And a lot of times we'll talk about it with flus and with diseases and with bacteria. And so here's the exponential growth or decay function. And then this applies to real life when things grow exponentially or decay exponentially, where things change a lot in a short amount of time. So this A is your initial amount. A is your initial amount. So we start with $100 or we start with 5 people. That's your initial amount. This is your growth or decay factor. That's your growth or decay factor. Most of the time it's a percentage, so it'll be in a decimal form. And then this is your time interval. Your number of years, 5 years. Your number of months, it'll be 2 for 2 months. Okay, that'll be your time interval. Now, how do I know if it's growth or decay? I'm going to look at this growth or decay factor. So when B is greater than 1, it's going to be growth. When B is between 1 and 0, so what does that mean? Between 1 and 0? Think about numbers that are between 1 and 0. Those are your decimals or your fractions between 1 and 0. That's when it's decay. So I'm going to show you some examples. Let's talk about when it's growth or decay. Okay, so let's look at number 1. So y equals 2 times 3 to the x. So is that going to be growth or decay? Well, let's look. The 2 is the initial amount. Okay, the 2 is the initial amount. So it started with 2 people. It started with $2. This is what decides growth or decay. And it's a 3. So that is exponential growth because it's above 1. What about if I had y equals 0.5 to the x? That's interesting. So whatever has your variable as the exponent is your B, is the growth or decay factor. So this is B. So where's A? What's A? A is A times B to the x. So what's A? What's in front that you don't see that's getting multiplied? In this problem, A is 1. B is 0.5 in this problem. So in this problem, your initial is 1. It's 1 person, it's $1, it's 1 bacteria. And then it's B is 0.5. So this one is going to be exponential decay. And it's going down because it's 0.5, which is less than 1. It's between 0 and 1. Let's look at another one. Let's do y equals 1/2 times 4 to the x. That would be number 3. I know how to count, I swear. And let's do number 4. Y equals 4 times 1/2 to the x. I'll give you a second to try them. Number 5. Y equals 3 times 3/2 to the x. And number 6, y equals 100 times 1.03 to the x. So let's think about those. I counted correctly this time, right? Proud of me? This thing is still, these curls are just doing what they want today. Whatever. Okay, here's number 3. So I'm looking at my B. It's a 4. So that's above 1. This is exponential growth. Here, I'm looking at B. It's a 1/2 exponential decay. Ooh, this one, 3/2. I bet you I got some of you. I'm guessing some of you said that it was decay. It is not. 3/2 is over 1. Yes, it's a fraction, but it's a fraction that is over 1. That's 1.5, 1.5. So this is growth. So just because it's a fraction doesn't mean that it's automatically decay. Think, think, think. Right, friends? So that's 3 over 2, which is 1.5. So that's growth. And this one is 1.03. So that's growth. So now let's think about number 6. My initial amount is 100, let's say $100. And now what's my growth factor? Let's think about this. So this would be my initial amount. And now here is my growth factor, 1.03. So let's talk about that a second. 1.03. This would mean like a 3% growth. Where would that come from? Well, 3% is 0.03. Well, when something grows, it gets bigger. So it keeps its full 100%, right? It keeps its 100%, and then it gets an additional 3%. Keeps its 100% and an additional 3% growth. Think about that a second. So 1.03 because it's growing 3%. All right, let's do some practice. Okay, so I'm going to give you an initial amount. So let's say the initial amount, and then this is where we're going to end. We're going to do some of these today, and this is the last thing we're going to do, is $150. So the initial amount is $150 for all of these problems. Let's say A is 9% growth. I want to write the equation. B is 12% growth. I want to write the equation. C is 300% growth. I want to work for that company. D is 2% decay. And E is 8.2% decay. Okay, so now let's think. 9% growth. So it is growing. It is keeping its 100%, and then it grows an additional 9%. Keeps its 100%, grows an additional 9%. So that is actually 109%. So Y equals, my initial amount is 150. 109% is 1.09 to the X. That's where that comes from. 12% growth is 112%. What is that as a decimal? 1.12. So Y equals 150 times 1.12 to the X. Ooh, 300%. 300%. What is that as a decimal? Well, where's your decimal right now? Right here. So where does it move? 1, 2. That's 3.00. So it's 100 plus 300 would be 400%. 400%, or 1.00 plus 3.00 will give me 4.00. So it's Y equals 150 is your initial, because I said so from the beginning. And then it's 4 to the X. Well, now it's a little interesting because it's a 2% decay. So now I'm not adding to 100%. I didn't get to keep my 100% and then add to it. I'm actually going down from my 100%. I'm going to say it again. I don't get to keep my 100% and add to it. I'm going down from my 100%. So I have my 100%, and then I'm going down 2%. So now I'm really at 98%. So this is y equals 150, which is my initial. And now I'm only at 0.98 to the x. So 0.98 told me I went down 2%. 8.2% decay. So I was at 100, but I went down 8.2%. So I'm really at 91.8%. Well, as a decimal, that is 0.918. So what's my answer here? Y equals 150 times 0.918 to the x. And then I could look at this and notice that it's down from 100, so I was definitely at a decay problem. Down from 100, right, in between 0 and 1, decay problem. Up above 1, growth. Up above 1, growth. Up above 1, growth. So it fits. And then I know that I'm right. You think about those. So what you're going to do moving forward is some practice problems on these growth and decay, some real life applications of these growth and decay issues, and where this is involved in real life applications. So we're going to look at these, analyze some more of these problems, do some practice like this, do some practice with real life. Then we'll move on next to some more word problems, some more application problems, and then we'll move on to a new topic. I miss you, and comment with any questions you have in Google Classroom or on Remind or in my email. And you're doing a great job. Can't wait to see you. Miss you, miss you. Talk to you soon, friends.